Hello and welcome back. Today's lesson is going to teach you some simple methods of how to use elimination to increase your math score quickly and easily on the test. We've talked about the many ways that the test differs from normal school, and this is no exception. There is no partial credit, which means the answers that you get and choose are all that matters when determining your score. This makes a proper strategy of elimination and guessing an easy and effective way to improve your performance quickly on the math section. Although it may not seem like it, eliminating incorrect answer choices is as vital a step towards increasing your score as choosing the right ones. Remember that every time you have eliminated an incorrect choice, you have significantly increased your probability of achieving a higher score. On the math section, there are a number of straightforward methods and ideas that we can use to eliminate answer choices quickly. Some examples include cases where a negative number appears in a square root, attempting to divide by 0, or negative values representing squared or absolute value quantities. This is by no means an exhaustive list. There are in fact many ways that answer choices may be eliminated quickly. So anytime you see one that violates a basic mathematical concept, eliminate it. Let's try a couple examples. If x equals 2y minus 3 and y equals 4z, then what is the absolute value of 3x plus 2 when z equals negative 3? Just glancing at this problem, we see we've got three different variables, and we've got three different equations, and then one final expression here that we're asked to determine given the set of circumstances. So it's a pretty complicated problem, and if for whatever reason you decide that the algebra is too tough, maybe you can't solve it, you just run out of time, there are things that we can do to eliminate answer choices quickly and give you a better chance of guessing correctly on this problem. So let's look at what this question is asking. What is the absolute value of 3x plus 2? Well, the first thing that we know for any absolute value is that it must be greater than or equal to 0. So any answer choice where that's not true can be eliminated immediately. And we see that A is negative 10, so we can cross that out. B is negative 5. And even if you don't know how to solve the rest of the problem, you've increased your probability of answering the problem correctly simply by eliminating those three answer choices. So at this point, you could guess and move on. Let's try another one. If the square root of 3x minus 9 equals y and x plus 10 equals z, then what is y when z equals 13? So again, we've got a pretty complicated problem here. We've got three different equations in terms of three variables. Maybe it's something that's a little too complicated for us, or we're out of time. If either of those reasons happen to be the case, like I said before, there's still some things that we can do to eliminate incorrect answer choices and improve our chances of getting the problem right, regardless of whether or not we're solving it. And here, the restriction of square roots will actually help us eliminate a couple answer choices. We know that in this first equation here, we can't have a square root equal to a negative number. And since this question asks us what is y, and y is equal to a square root in this first equation, we know that automatically we can eliminate these negative answer choices A and B again. And even though we may not be able to solve the rest of the problem, we can simply just take a guess and move on if we're out of time. Don't forget that anytime you can eliminate even a single answer choice, you should guess. Sometimes we can simply use eyeballing or estimating to eliminate answer choices which are obviously incorrect. Let's take a look at an example. In the above figure, ABCD is a square of side 3. I'm just going to label that here. If length AE is 5, what is the area of quadrilateral ABCE? Okay, so we're asked about the area of this entire shape. And we know that this is a square of side length 3. So if we were kind of running out of time for whatever reason, we're in a huge hurry, we could use the lengths that it gives us to make a preliminary estimate and use that to, like I said, eyeball a solution to this problem. 3 times 3 is 9, and just looking at this thing, this triangle looks to be about half the size of the square here. So maybe we call that 5 or 4. I'll just write down 5 here. So we know that our answer choice is around 13 or 14, just based on a preliminary eyeballing estimate. So let's look at our answer choices here. We've got 9, 12, 15, 20. We can quickly see that there are only two answer choices here which look pretty close to the numbers that we've chosen, 12 and 15. Everything else, I mean, we know that our square here is 9, so it's got to be bigger than 9. And we know that 20 and 25 both seem far too large to be correct on this problem. So fortunately for us, even just by eliminating using estimation techniques, we've gotten rid of 3 answer choices, and now our chances of getting this problem right, even if we didn't know how to solve it, are down to 50-50, which is pretty good. When using this technique, it is very important to be aware of one particular case where it's strictly forbidden. When a problem informs you that a diagram is not to scale, it means that it has been drawn in a way to intentionally mislead you. In this case, you must not use eyeballing, as it can lead you terribly astray, like in this problem. So we've got the same shape as we saw before, but the difference this time is the fact that it's indicated that the figure is not drawn to scale. Let's take a really quick look at what happens if we try to use eyeballing on this problem. It says ABCD is a square of side length 5. So using our estimate from before, we would call this 25, and we would say this looks about half the size of that, which means that it would be about 12, 13-ish, which means our answer would be in the range of 37 to 38, and we end up eliminating probably D, E, and maybe even A and B. But what happens here is when we take the other information into consideration, we make a more accurate calculation of what's actually true in this problem. Like I said before, the fact that the figure says the figure is not drawn to scale means that it has been drawn to intentionally mislead us, and we cannot use those estimating techniques to make a reasonable estimate of what the correct answer for the problem would be. Let's take a look at why exactly. The rest of the information presented in the problem is if length AE is 13. And if you know your special right triangles well, you might start to see one of them pop out here. The fact that this triangle has side lengths 5 and 13 means that the third side here is going to be 12. Like I said, 5, 12, 13 is one of those special triangles that we've learned about. So let's use our new numbers to make a reasonable calculation of what we can expect the area of the larger quadrilateral to be here. We know that the square is still going to be 5 by 5, therefore it has an area of 25. And the triangle here has dimensions of 5 for height and 12 for length, and we know that the area of a triangle can be calculated using 1/2 base times height. So let's plug those numbers in. If the base is 12, the height is 5, we get 1/2 times 60, which equals 30. So the area of this entire shape is going to be equal to 25 plus 30. And wow, that is a very different number than the one we used in our estimation technique. In fact, 55 would be one of the ones that we had eliminated using eyeballing. So like I said before, do not use eyeballing when you see that a figure is not drawn to scale, as it will be drawn that way to intentionally mislead you. You can, however, also use estimating or eyeballing on questions without diagrams, like this one. This happens to be an arithmetic or algebra example, but we can still use it here. If 55% of a number is 9 less than the number itself, what is the number? So 55% of a number is about half of a number. In fact, then it also tells us that it's 9 less than the number itself. The fact that it's 9 less means that, we've subtracted 45%, which is about half, and reduced the number by 9. So we know that the number 9 is almost equal to 1/2 what I'll call n for the actual number. Now using that would indicate that the number itself, we're fairly close to 18. Now we can't say if it's going to be exactly 18, maybe it's 19, 20, 21, 22, whatever it may be. We can use, like I said, our eyeballing to eliminate answer choices which are obviously incorrect, however. And in this case, the number 10 is very far from 18, and the number 40 is also incredibly far from 18, so we can toss those right out the window. And even if you can't algebraically solve this problem for whatever reason, maybe you just ran out of time, maybe it's not your best subject, we can still use, like I said, eyeballing to get rid of some of the incorrect answer choices, and in this case give you at least a 1 in 3 probability, which is something that you should guess on to get the problem correct. So at this point we would simply guess and move on. And on student response questions, or grid-in questions, there is no guessing penalty. So even if you can't solve for the value requested on a student response problem, just guess anyway. You might get lucky, and there's no penalty, so it's in your best interest to do so. Also, there are no negative answers allowed in this section, so if you come up with one, go back and recheck your work. The same applies for answers which are larger than 9,999. Since those answers would require more than 4 digits to represent, they are also not possible as answers on this section. So let's review. Unlike normal school, guessing and eliminating are powerful techniques of increasing your score on this test. Don't forget that the final answer is all you are graded on, so finding 4 incorrect answer choices is literally just as good as finding 1 correct answer choice. That's all for today's lesson on guessing and eliminating, and we'll see you next time.